Okay, so in this next problem, we're going to be using, again, distance formula to calculate and determine whether PQRS is actually a parallelogram. So the first thing we do is find the distance between points P and Q, and we find the distance between points Q and R, and then between points R and S, and then lastly we do points P and S. So to find the distance between P and Q, we would use the distance formula, which is d squared is the change in x coordinate squared plus the change in a y coordinate squared. So the change in the x coordinate going from -4 up to 6, that is increasing by 10. The change in the y coordinate from 2 to 4 is increasing by 2. So that's 104. Okay, but remember that's d squared, so you have to square root both sides of the equation to get d by itself. Okay. Next we'll do QR. So I won't write the formula this time, but from 6 to 11, the change in x is 5. We have to square that. The change in y value is that it goes down by 6. And so 5 squared is 25, 6 squared is 36. Remember, the negative sign cancels out when you have it squared. So here we get 61, and then don't forget we have to square root that answer. Okay. Next we'll do RS. So for RS, the change in x value is that it goes down by 9. And the change in the y value is that it goes down by 1. So that's 81 plus 1, which is 82, square root. Okay. And finally we have PS. But we could already notice that since we have 3 different numbers, we could say that this is not a parallelogram, right? But just to complete this, to do PS, we would do change in x would be going up by 6, and then the change in the y value is that it goes down by 5. So we have 36 and 25, so that makes a total of 61 square root. Okay, so it's true that these are equal, but it's not true that these ones are equal. So we would need 2 pairs of equal sides for it to be a parallelogram. Therefore, we know that it's not a parallelogram. Okay, so next we're going to be looking at how to determine whether a figure is a parallelogram by using the slope formula. So to use the slope formula, we would do something similar to what we did just a moment ago. So we would start with wx, then go to xy, and then yz, and then wz. But this time, instead of finding the distance between the 2 points, we're going to find the slope between those 2 points. So to remind you, the slope formula, m stands for slope, and that's equal to the change in y divided by the change in x. Okay, so first we'll start with the y values between w and x. So the y value is subtracting by 2, and then the x value is going up by 8, and that you can reduce to -1/4. So next we'll do xy, and for xy, we'll start again with the y values. So the change in the y value is that it goes down by 7. And then the change in the x value is that it goes up by 4. So that will be our slope. For yz, the change in the y value is that it goes up by 1. And the change in the x value is that it goes down by 4. So we have basically -1/4. And for wz, the change in the y value is that it goes down by 8. And the change in the x value is that it goes down by 8. Sorry, this is the wrong formula. I'm going back to distance, but down by 8 in the y value, and in the x value, it is going up by 8, right? So we'll get -1 for that. And I would say that no, this is not a parallelogram. Okay, the reason why is because we would expect to have two pairs of equal numbers. So these are equal, which is good, but these are not equal, which means it's not a parallelogram. Okay, so now you can try number 4 on your own.